All right, in Algebra 1, you should have learned how to solve simultaneous equations, but this will just give you a quick review. So you have two basic types of equations when you're solving simultaneous equations. This one here, none of the variables have a leading coefficient of 1 or -1. But over here, you can see this one here has a leading coefficient of 1. So that's the first thing that I take a look at, because I will solve them differently based on just that. Do they have a coefficient of 1 or -1, or don't they? So the two ways that you can solve this is called the addition method or the substitution method. So let's go ahead and take a look at this one here. So in the addition method, and sometimes it's called other things, what you want to do is you want to make sure either your x's or your y's add to 0. Well, right now, if I add these two equations, neither one of them will add to 0. So I either have to get this to be a -4 so that when I add these together, it will add to 0, or I have to get this to be a 6 and this to be a -6, so they would add to 0. And it doesn't matter which one you choose, but it looks like this would be a little easier. So I'm going to take this whole equation here, and I'm going to multiply every single term in this equation by -2. So when I do that, I'm going to get -4x. When I multiply -2 times 3, I'll get -6y equals a -22. So now I'm going to add this equation and this equation. So I'm just going to get rid of the middle equation just so that it doesn't confuse us. All right, so if I add these two equations, this 4x and this -4x will add to 0. -2y minus 6y will give me a -8y. And a 30 minus a 22 will give me a +8. So if I'm solving this, I'm going to divide by -8. And I now know that y is -1. But don't forget, you have an x and a y, so you can't stop here. So you're going to take this -1 and plug it into either one of these equations. It doesn't matter which one you choose. I'm going to choose this one. So I've got 4x minus 2. Instead of putting y now, I'm going to put -1 equals 30. So 4x plus 2 equals 30. I'm going to subtract 2 from both sides, so 4x equals 28. And now I know that x equals 7. You're going to write your answer as an ordered pair, x, y, so x will go first and then y. So the solution to those simultaneous equations is 7, -1. So that's your addition method. Let's take a look now at what I would do for substitution. So in substitution, since this has a leading coefficient of 1, I'm going to solve this equation for x. So if I'm going to have x equals -5y plus 31. Now I have an expression for x. So I'm going to take this expression and substitute it into this equation everywhere I see x. So here I have the 4. Oh, I have an x. So now instead of writing x, I'm going to write -5y plus 31, because we've determined that -5 plus 31 is x. So I can just take this expression and plug it in for x. I have to continue the rest of the equation. Plus 3y equals 39. Now I just have a simple linear equation. I just have to distribute the 4. So I'm going to get -20y plus 124 plus 3y equals 39. I'm going to combine all my like terms. So I'll have -17y plus 124 equals 39. I'm going to subtract the 124, so I'll have -17y equals -85. And then just divide by -17, so I'll have y equals 5. Once again, I have two variables, so I have to substitute this 5 into either equation. Well, this one looks like it's a little bit easier to substitute it in. I could substitute it into this equation as well. It doesn't really matter which equation you choose. So I'm going to say x plus 5 times 5, because my y here is 5, equals 31. I'm going to have x plus 25 equals 31. So I'm going to have x equaling 6. So once again, if I write my answer as an ordered pair, it will be 6, 5. So those are the two methods to solve simultaneous equations.